Okay, so for the past maybe 1 week, I received many questions regarding, I will summarize as the issue of client-server relationship. So people are asking, oh, this is HW3 client, HW3 server, and sometimes the client can play the server role, sometimes the server might play client's role. So it's quite complicated sometimes for you to answer the question like who's client and who's a server. So we're going to address this issue today. So let me actually first to talk about what is a client and what is a server. And I'm going to use a very simple example to illustrate that. So first, let's talk about function call, or in C++ context, this is what we call the member function call. So I write a very simple example here that we have a class called X class. And it has object called xc, and has a member function called foo. Let's just make assumption like this. So on this side of the code, I'm actually calling this member function call. So it's the xc.foo. On the other side, which this is another piece of code, which is the implement the member function for foo for class X class. And they usually have this kind of format. So you can think about, in your example, this could be, say, person.cpp, and this could be some kind of test driver program for that object. Okay, so essentially we're making a function call. From one side is the implementation of the function, and one side is actually the piece of code that's trying to invoke that function. Okay, that's we encounter. This is not new for you guys in ecs36b. From your first programming course, you should already encounter this kind of function call. It might not be member function call, but it's definitely function call. Has this kind of structure that one side call the other. Okay, so I'm actually trying to provide some terminology, and sometimes you hear me saying caller and callee. So this is basically on the left side is caller. I'm actually making a call, and the right side is callee, the one is being called. Okay, or you can actually use other terminology which I try to relate together to client server. And one is, say, requester, and the other side is responder or initiator or receiver. So for example, what is a requester? The requester is the one on the left who is requesting the service for foo from this object xc or from the other segment of code. And the thing is that this piece of code being executed in the foo, this is a responder, because when you view a function call, it's just receiving a request to perform what you need to perform within that function call, whatever foo, whatever get VSID or conflict of interest or whatever function, or the get GPS, calculate GPS location. Okay, so this has been a very same structure between the function and as well as the client server. So hold on, go to the. So basically, I call it the left side. Sorry, the right side. I call the service provider. So in this case, foo is a service, and when you make a call, you're really doing a service request. Okay, you're really doing a service request, and then you got that service taken care by the piece of code running on the right side of the slide. Okay. And to make it a little bit complicated, that we actually introduced this concept to you in homework assignment number 3 called remote procedure call. So in other words, what we're really doing is just separate this two pieces of code, the requester and responder, in two different locations. And in this case, that on the right-hand side, that on the left-hand side, basically is running on a machine, but it's still making a request. And the right-hand side is a responder. Okay, and then basically there is a piece of code we call RPC, JSON RPC code that's generated, which we will see the example, how they connect toward the end of this lecture as well. You will be able to see the code. But this just telling you that the same structure between the requester responder doesn't change when you extend from the traditional function call to the remote procedure call. In fact, you could have a client server even on the same machine as well. All right, so now we're going to ask two questions. So after you see the relationship between the function call and the client server, that the two questions I encounter so many times this week is this two. So the first question is, well, how do I actually identify the client server relationships within a particular scenario? All right, I mean, for example, a student asked me, is HW3 server, is it a client or is it a server? For example, the question like that. The reason that is important because it turned out that it depends. And in the case of HW3 server.cpp, because it will serve the role likely for both client and server, so it needs to include the include file that's actually for both client and server. So you almost always have to include both because you might have a different role there. But we'll see how you can identify the client-server relationship. And the second question, which is very uniquely applied to homework assignment number 3, is that the students are asking, well, exactly what happened in JSON-RPC? When I have a client-server call, when I have a remote procedure call, exactly how the flow of information and flow of control will pass from one end to the other. I mean, this question is related to two things. The number one is just try to understand how is JSON-RPC work as much as we can from the code that's provided to us. And the second thing is that we would like to know that what are the information and where they are in passing and coming back in this request and responder relationship in the JSON RPC. Okay, so this is two questions I'm going to address today. Okay, first let's look at the first question and try to see, well, how do you identify the roles? I'm going to give an example in HW3 client, assuming I'm going to do a operator equal. This is overloading. By the way, the way to call a operator overloading is the first line here. Okay, is you just say as if it's not operator overloading, you just say P1 is equal to P2. That's the right way to call it. I mean, conceptually is equivalent to P1 dot operator equal parentheses P2 conceptually. But in programming language, linguistics, C++ does not allow you to specify this way. If you try to call operator equal operator, any operator overloading using this operator like this, it will be a syntax error. So just let you know, if you don't know, look at the textbook or look at my lecture on the operator overloading. Okay, so that's the example I'm going to give you. So so it's actually going to call, but the thing is that the object in the target, P1, the P1 is actually being located in another machine, HW3 server. So let's just assume that this is the example. So I'm actually going to make a call for operator overloading on HW3 client. But P1, which is the object, is going to be respond to the request, is actually on the other machine. So essentially what we want to do is actually we want to call the function that's actually being hosted in person. And therefore, in this particular example, you can see that the request got delegated by RPC to the HW3 server, and which the P1 is really located. So in this case, for this particular relationship about function call or client server, that the HW3 client is the requester. So therefore, it's a client. And the HW3 server, which is where P1 is located, is actually the responder is a server. So in this pair of relationship, it's very clear that who is a client, who's a server. So essentially, client and server is decided not because the name of the program. It's depending on how is the flow of function call. Who is the request, this function call? Who is the response to the function call? And maybe both of them are sitting in the same machine or the same program, that's fine. But there's still a client-server relationship there. It's depending on who's a requester, who's a responder. Okay, well, unfortunately, when you call operator equal the P2, which is a person, if you remember the code that we put it in shadow person, so a person is P2, and the P2 is actually on the other machine, yet another machine. We call it HW3 another. So in this way, that when you want to implement the operator equal in HW3 server, you're going to obtain the VSID for P2. And so now this is a new request, because this request is, again, a function call. I try to obtain the VSID of a particular object. In this case, the object is yet in another machine. Okay, so now we have another relationship between the HW3 server and HW3 another. Okay, and in this case, now the role changed a little bit, because now the segment of the code requesting this function is actually from HW3 server, and the code respond to that is actually in HW3 another. So in other words, now we're actually has a different role. Now the HW3 server is the requester, it's a client, and HW3 another is the server. So again, this is not based on the name of the program, but it's just based on the relationship of any kind of call you try to provide as a service. Okay, so that's what we see that for the interesting part. You can see that now HW3 server is serving both person and shadow person, and therefore it needs to include all the include file for both the client and the server side. Okay, so now make it even more interesting. We'll talk about web report. Looks like this. When there are object, we talk about there are 4 JSON you need to return. And now we move that into this picture. So you can see that when the first call happened from the HW3 client to HW3 server, we actually need to report 2 JSON from, I'm going to show you what are those JSON at the end of this lecture by looking into the JSONRPC code. And so you can see that there are 2 of them will be delivered from the client, and 2 of them will be delivered from the server. And what's now interesting is that both of them, when they communicate with a web report, they're both requester or initiator. Because why? Because I want the server to publish that particular JSON to me, for me, on the web link that you can check whether your submission is successful. So essentially what you're doing, web report itself is a service, and the web report server is a service provider, and any program try to report is a client. So in this case, that the HW3 client is a client because it's a client toward web report. And similarly, HW server, when they report, they're also client. They're actually looking at that. Again, we're saying that you have to look at what service we're talking about, then you see which side is a client and which side is a server. And similarly, when you do this get VSID, that this 2 side of get VSID is also need to report. Each of this is going to report 2. And the thing is that the whole thing over here, both this program, their client, correspondence to the web report server. Okay, so that's hopefully by illustrate this, it give you a clearer view about how do you decide which is a client server. Sometimes it's really depending on what are the services and who is requesting that, who is respond to that. Okay. All right, so let's actually conclude the first question. The first question is, well, how do I identify client-server relationship within a particular scenario? I mean, we cannot simply call a particular program the role of a server or a client. It really depends. What I'm saying is it really depending on the requester and responder relationships, okay? And the other thing which I have been working, I added the green parentheses among the objects. One of the unique perspective about object-oriented programming is that instead of for you to think about a program is just a what we call flow chart. I mean, some of you probably see this flow chart describing the logic about what's the beginning of the program till the end. That's one way to look at non-object-oriented programming. It's okay to think about that way. In object-oriented program, that flow chart is insufficient, in my humble opinion, to describe what we really want to accomplish or the potential of object-oriented programming. Object-oriented programming is really trying to define what are the object, what are the interface of the object, what is the internal of the object. We try to define the object mapping the realistic scenario we try to deal with. But then after you define the object-oriented programming also need to define how objects are going to interact with each other. They're going to relate to each other. And that is the requester-responder relationships we need to worry about. So that's why I'm actually telling you is that to learn object-oriented programming for the first time, you have to actually give up a little bit about what you learned from your first course about this flowchart concept. You have to actually think about object-oriented programming is just a bunch of things that in front of you, and you worry about, well, how do I describe them using the language I have, and how do they actually be able to interact with each other? So sometimes it's not going to be a claim to be, this is always client, this is always server. Instead, you will have a picture looks like this. And you define those things everywhere. They're interacting in a way that's best describing what the problem that you're trying to solve. Okay, so that's summarized my first question. Any question before I move on to the second question from the class? Okay, I'm going to move on to the second question. The second question is really trying to dive into the information flow about JSON-RPC. I mean, you might or might not have done the exercise I'm going to show you, and you will be able to handle that. But it will be good for you to actually dive into this code that's being generated. So one thing about JSON-RPC, I mean, this is among other things in this class that I want to just to advise you about my opinion about learning programming or coding. There is one of the goals, which of course the first order goal about programming is teach you how to write a program. That's called the writing ability of a programmer. And I think this equally important, or even more important, is the reading capability of a student about code. So writing is you try to write your code, and then you get this piece of code to work. And the reading is actually harder, because reading is trying to understand other people's code and understand what they're doing, or try to extract a segment of code from another person's code and try to reuse segment of code from that. So you can see that code reusability is so important today. So reading capability is something I like to emphasize. I want to share with you is that sometimes if you don't understand somebody else's code, it will be really good for you to ask that question and within this class to me or to TA, to other students about what this code is doing. And that really triggers you to learn a lot more effective than you try to write everything yourself without exercise your reading capability. Just tell you a little bit about my computer programming instructional philosophy. This is my philosophy, is that there are just way too many things you can learn in programming. There's just way too many. I mean, when we are talking right now, there are new library, new platform, new language, or new way of doing certain things are being created as we speak. So it's really hard for you to master everything. But the thing is that the reading capability is that when you are touching a real problem, that you realize that this is something that you need to solve your problem. At that time, the reading capability on Stack Overflow or JSONRPC is really going to help you just learn that segment and to solve the problem. So you learn through the experience of programming, solving problem, and you learn those are necessary for you to do the work for the next couple weeks. And then gradually you will experience and you will learn more and you see the trend. But the thing is that in programming, I feel reading capability is very important because there will be just new things. This is, by the way, the blessing and the curse of a career of a computer programmer. A lot of us have to keep reading new things, learning new things. Okay, so having said that, that's just my philosophy. I mean, I could be wrong, by the way, because different instructor holds different belief about how you should balance between the writing and the reading ability. Okay, but I think this, following that philosophy, I just want to read a piece of, I invite you to read the code that's generated by the JSONRPC stub program. Okay, so essentially what we're saying is that, okay, if Felix write the code, you say, okay, that's his style or his reasoning. But if the code is generated by a program and that piece of code has been used repeatedly by hundreds of thousands of programmers when they're doing the real world application, and that's interesting because why they generate that code and how that work, it really help you to learn the real world situation. So in particular, we're going to watch this two pieces of code. If you haven't done this, is this two pieces of code in homework 3, they're generated, HW3 client.h and HW3 server.h. Okay, let's actually look at this two pieces of code. So first, I want to look at just a small piece of code under HW3 client.h, which is get distance. Let's actually just use this call. So this piece of code in front of you is of course generated is based on ecs36b underscore hw3.json, which has a function called get distance, and it has 6 arguments as you define over there. It's called action, argument, class ID, host ID, and the object ID, and the owner vs ID. Okay, so it's a JSON. They're looking at the data type of that specification. They understand all of them are string. So they basically, it's not new. It's basically pick up from the .json configuration, RPC configuration file. That's what I call it, to actually generate this piece of code. Okay, so that's the function. But the important thing is I want you to see the request and responder. Request responder, where do I go down and then to produce that? So the call really to the server side is this line, this call. You see that if you can see my mouse is this call method. So this is a place, this is a line that it requests a service from the other side. Okay, it's called call method, is just one function, but this call method has 2 parameters, 2 arguments. The first argument is the name of the function on the server side. Okay, so get distance is the one I like to call. And the second argument is very interesting, it's P. What is P? P is the JSON that putting all the argument encoded, all the argument into a JSON format. So by the way, what's P? P is JSON column value. It's a JSON object. And you actually shuffle pieces, the name of the function and the argument that you need to know, you need to use for the function, and then that's the JSON encoding about all of the 6 arguments. How do they encode? JSON programming. P action, P arguments, P class ID, P host URL, object ID, owner VS ID. That's exactly match what we have here in the argument, exactly match with what your RPC configuration file. Okay, so when you make the call, you're actually getting a result. This result is also a JSON value. So essentially, I put the argument there, and I actually get the result back. All right, so this is the entry that's really making the call. If you see other function like conflict of interest, operator equal, and get VSID, they have exactly the same structure. Exactly the same structure that's actually initiate the call. So this is the initiator. So just slow down a little bit. P, by the way, is JSON number 1, and result is JSON number 4. Okay, so this is the argument. But the only JSON number 1, you need to add your own VSID, and also you need to add your own VSID into result. If you've done this too, you can actually submit this to the web report. Okay, this is basically the code that's actually from the client side is HW3 client.h. Okay, let's actually look at the server side. The server side, this piece of code is also generated. This is from HW3 server.h. And you can see this is that it's actually calling the function this get distance. By the way, when this get distance, this is actually going to call the code that you provide in HW3 server.cpp, because in HW3 server.cpp, you have this function, you have the member function declare, get distance, as well as conflict of interest and those things. Okay, but over here, let's look at how is get distance get called. This is how is the other line call method request into the JSON-RPC, and then call this function called get distance I. Okay, and this is called get distance inline or whatever they call it. They add I there to differentiate. And this is essentially, if you look at the function, this have a 2 argument. These 2 arguments are both JSON. They're both JSON object, and they're both reference to a JSON object. They're both called by reference. By the way, when I check with some of the students know the concept of the difference between call by value, call by reference, and call by name. Those are the 3 concepts in programming language. I know some of the students got it from ecs36b, and some of the students probably didn't get to expose to exactly the term, but the concept of call by reference is very important. I think one of my lecture recorded talk about that. I will direct to you if you don't understand, you want to learn more about call by reference. Okay. But here you can see there are 2 JSON. One is the request, one is the response. So request is essentially what? It's a P that's being passed into here from the other side, from the previous slide. It's the JSON P go into this request. And what's response? Response is the one that's going to feed back to the call to the result. So essentially, request is JSON number 2, but it's also JSON number 1. From the P, from the other side. And response, which is JSON number 3, is the same as result. Okay, so understanding that, so we can actually see what's inside of this get distance I. So look at the request. Request the P we just encode, and look at what they did. They actually go to the request, the JSON, they extract exactly the 6 things out for you. Those 6 action, argument, class ID, host URL, object ID, and owner VSID. This is exactly the same string. You encoded the JSON on the client side. Now you just extract it out of the JSON. And because it's defined as a string, okay, who defines the string? You define. You actually define that in the RPC configuration file, the ecs36b underscore hw3.json, because you declare as a double quote string, so they actually interpret as this is a string. So they actually extract the string and they call the method that you have in hw3 server.cpp or hw3 another.cpp. So if you go in there, you will see that that's exactly match this 6 argument over there. Okay, and this function call is going to return. And if you look at the code, HW3 server.cpp, at the end, you're going to return result. And that result get copied into response, called by reference. And therefore, this response will be returned. So in your HW3 server.cpp, you will see that at the end of the function, you always return the result. And that result is actually JSON number 3 because it's shuffled into response. And the response will be passed back to the original requester from the client side. And that client is going to look at this, assign into this result. Okay, so that's how the information flow. And this actually teach us 2 things. Number one, it teaches us how is internally in this generated code, how is a call being handled, how the information flow, how the encoding of JSON is being done, or decoding or extracting. And also it's important for you to understand where do you actually look for information, what information is exactly passing over there. Okay, so that's my second question that I would like to answer. Okay, so these 2 are the things I feel this is almost like a most commonly asked question for the past few days regarding the development homework assignment number 3, part 2. Okay, so I'm going to stop here. Are there any questions?
Professor?
Yes.
So for homework 3 server.cpp, since it's also a client, we will need to include a homework 3 client.h, right?
Yes, you have to basically have the same kind of code that you will put in the client side or WR client inside of HW3 server.cpp. There are 2 things you need to worry about. Number one, you need to include the code that's actually being added to those 4 functions in the server code. When you add the code, make sure that you don't reuse. You might need to change the parameter. For example, you might need to change it because you might already have one variable for HTTP client defined for other purpose. You just need to change the name. That's number one. Number 2, what you need to do is that in your include file, the typical HW3 server only file only have the RPC server include file. You need to add the client file as well. So let me actually show you an example if I still have it. Hold on 1 second. Let me see if I have this here. No, not this one. Maybe I put it in a different file. Okay, I will use this. It's easier. I know this will work. So in the HW3 client, I'm actually including Shadowfly. Okay, in Shadowfly .h, you see that I actually include this few line, this 2 line especially. This 2 line of code that both for client, HW3 client.h and JSONRPC CPP client connectors, HTTP client. You need to include this 2 line in HW3 server.cpp as well, because without this 2 line, it cannot perform the client function. It can only provide the server function. So in other words, that your program should have both of them. I know for some reason it should be already there, but let me show you how I will do this. So it should looks like this one should have this. It should have both of them, okay? That should be your server. In fact, these two will not conflicting each other. So don't worry about that. You include both of them and everything will work well, because the client server mixing scenario is very common in most application. So therefore, they're already taking care of any possible conflict that's actually will occur in this scenario. Okay,
Okay, thank you, Professor.
you're welcome. Any other question? Okay, so what I'm going to do, I'm going to stop recording